Good morning, everybody, and welcome to our official webinar on DEHN surge protection devices. We're very excited to host this webinar. It's actually hosted by DEHN, and we have Alan, who is the DEHN Key Account Manager, as well as Stefan, who is the DEHN Electrical Engineer. And Stefan will be presenting the webinar this morning. The webinar will provide an overview on different types of surge arresters in DEHN, as well as why it is important to have surge protection, and also how to distinguish the different types of wave shapes you might find in surge arrestor. Stefan will also be speaking about external lightning protection in industrial building, as well as manufacturing facilities. So before I hand over to Stefan, I just wanted to run you through a brief overview in terms of the controls. So you will see at your screen, there are a few toggles. There's a chat and a Q&A, as well as a raise your hand function. If you'd like to talk, please raise your hand. We will then open the floor so you're able to physically talk. Please make use of the Q&A and the chat functions if you do have any questions throughout the course of the webinar. Just to hold all the questions until the end of the webinar, but if you do have any questions throughout the course of the webinar, please make use of the Q&A or the chat function. Do have your catalog on hand if you want to refer to any part numbers, or you want to chat to Alan and Stefan about any of the particular products that you may have a question on. And there will also be a poll at the end of the webinar. Please assist us by completing the poll. It will take 2 minutes of your time. And the idea behind this is just to help us improve your experience on the webinar. So that's it from me. And without further ado, I'd like to present Stefan. Thank you.
Hi, Karen. Thanks for the introduction. Hi, everyone. Thanks for joining us on this webinar today on surge protection devices. As Karen mentioned, we're going to discuss the basics of surge protection devices, the different technologies DEHN incorporates with the surge protection devices. Yes, so without any further ado, let's get started. So DEHN is a German-based, family-owned company, active in more than 70 countries in the world. We have more than 23 subsidiaries across the world. Also, we are not only manufacturers of surge protection devices, but we also have and manufacture external lightning protection. That includes your air termination rods, your finials, and your earthing systems. So basically, DEHN is not only a manufacturing company, we also have an engineering department where we do designs and risk assessments. We provide solutions for a lot of different industries. As you can see from the image, we have different solutions for your wind energy sectors, your energy generation, which is more your PV systems, protection for your cell sites. We have protection for communication systems, energy distribution facilities, as well as your railway systems. So the requirements of an SPD. SPD, as per standard IEC 62305, a arrestor needs to fulfill certain requirements. A surge protection device should be able to repeatedly discharge lightning currents without any destruction. The SPD also should have a voltage protection level lower than the electric strength of your downstream electrical devices. And it should also be able to extinguish or limit the mains follow current from the supply system as not to damage your electrical systems downstream. The SPD is also, it's very important that the SPD should coordinate with any downstream surge protection devices that you need to install. So the causes of transient overvoltages. This can be caused by a direct lightning strike to a building. With this, a lightning waveform is associated by 10/350. What this means is that it takes 10 microseconds for the lightning current to reach peak value and 350 milliseconds to reduce to half of its peak value. Transients in your system can also be caused by an indirect lightning strike next to your building. Due to the high frequency behavior of a lightning strike, there's a changing magnetic field. If you have a changing magnetic field, you induce current and voltages onto nearby power or telecommunication lines. This is described by the inductive and capacitive coupling that a lightning strike has. Surges are generally defined as a H/20 waveform, which means that it takes 8 microseconds for the current to reach its peak value and only 20 microseconds to reach half or to reduce to half of the maximum peak current. Another cause of transient overvoltages are your switching operations that could come from the utility when Eskom does have load shedding. Switching off large inductive motors. You also get surges into your system with earth faults or short circuits within the network, and also tripping of fuses, as well as parallel installation of power and IT systems. As described earlier, a lightning waveform is described as a 10^350, which is indicated by the red graph in the image, as well as your H/20, which is your surge current, shown in the green line on the graph. So this next slide will indicate to you what's the differences between these two graphs and why it's important to install the correct SPDs depending on the expecting lightning current that you might expect. So from the test, we decided to do we choose the same current magnitude at 40 kA with a different type of wave shape. So from this video, you can see that the first test was conducted by injecting a 40 kA peak lightning impulse system. You can see from the graph that nothing happened to the installation at H/20. Now with the same current magnitude, injected with a 10^350. So from this, you can see that depending on the wave shape of your current, the amount of energy transferred to your electrical system with only a surge protection device and an external lightning protection device is the amount of energy. This image shows some damages caused by lightning currents. As you can see that a circuit board has been fried completely on the left-hand side, and on the right-hand side, a cable was struck directly with a lightning strike, and it actually damaged the whole cable, which needs now to be replaced. We've also seen damages in switchgear cabinets, cabinets that did not have any surge protection devices. You can see that the lightning strike actually came into your electrical system and caused arcing, which caused the circuit or the switchgear cabinet to catch fire. Especially in our PV systems, there's a lot of damages associated with that due to your inverter. The inverter consists of very sensitive electronic devices, which is subjected to a lot of transients over the course of operation. And if any of these transients are too high, it can cause damages. That's why it's important to also protect your inverters with surge protection devices. So the risks of a lightning strike. All the systems are interconnected. You have your power facility, which then supplies power to your hospitals, your residential areas, or your urban areas. It supplies power to cell sites. It supplies power to, or it's connected to your renewable energy sectors, as well as your industrial facilities. So a lightning strike doesn't have to happen at your premises to cause damages. It can happen at any part of the electrical installation. And due to the connected nature of the electrical systems, the lightning current can come back onto the power lines into your buildings. And that's defined up to 2 kilometers away. That lightning can have an effect on your your system. Examples of this is that you have a direct lightning strike. As you can see, from the residential area, you have your earthing system that's been fed by an underground power cable, which then goes to a transformer, and then you have your overhead connecting lines connecting all the different parts of the networks together. So now, one cause of lighting damage would be a direct strike to your building. The lighting current will flow to ground, creating a voltage drop across the earthing system. And also that same effect induces a current or voltage between your telecommunication and power lines. These voltages are usually in a range of above 1,000 volts, which is too high for your equipment to withstand. Another example of lighting damage is for your remote lightning strikes. First of all, if you get a direct lightning strike on an overvoltage line, overhead high voltage line, that lighting current is now on your power cables going into the transformer and is conducted via the power cable into your residential area. Another cause of damages can be surges by cloud-to-cloud lightning strikes. That magnetic field associated with the lightning strike can cause transients on your overhead line systems, which is then connected via the electrical lines into your building, which can cause overvoltages within your electrical installations. Another reason for damage is a lightning strike directly next to your residential area. Again, with the changing of magnetic field, you induces current and voltages onto your electrical system, which can cause damages. The standard IEC 62305 Part 4 defines lightning protection levels. These levels are ranging from a level 1, which is your highest lightning protection level, to your level 4, which is your lowest lightning protection level. These levels are determined by a risk assessment based on the building you're protecting. So the standard defines a lighting level 1 as a peak magnitude of 200 kA current that you can expect on your electrical system, where your level 4 is 100 kA of lightning current you can expect. To give you an example of this, let's say the external lighting protection system installed on your building with a transformer, which is supply, and you also have a system installed on the roof. You have your 230 volt single phase voltage coming into your building, as well as your 1 ohm earthing resistance. So let's say you get 100 kA lightning strike to your lighting protection system. 100 kA will flow on the down conductors to earth. Using Ohm's law, you can actually determine the voltage rise based on the current that's flowing into your earthing system and also the resistance of the earth grid. So you can expect 100 kA to be present on your earth bar. This high amount of potential difference between the 100 kA that's now on your earth bar, and that feeds into all your electrical equipment, and your 230 volts electrical supply, this high difference in voltages can cause flashovers or sparking. And that's bad for electrical installation, because what it does, it damages your electrical systems, and also it gets a chance to actually start or create a fire condition. Another example of SPDs and how it's actually rated is you have your lightning strike to external lighting protection system. This is in this case a 200 kA strike, which is your lightning level 1. The general rule of thumb is that half of the lightning current will actually dissipate into ground, and another half, the other 50%, will go back onto your earthing system. Now you need to install the correct type of SPDs to be capable of withstanding the 100 kA lighting protection or the 100 kA lighting currents. This is done via 25 kA arresters, which is 25 kA rated per module. So the lighting current splits into 4 equal currents into your electrical system. This 25 kA per line goes back to your transformer station and then goes to ground. Lighting protection zoning concept. So generally the lighting protection zoning concept is defined as you have a lighting protection level 0, which is on the outside of a building, and you have your lighting protection zone 1, which is, for example, inside your building. So the standard defines as you need to place surge protection devices or do equipotential bonding if you move between zones. So let's say you have your electrical power line that's coming from outside into your building. So this means that if you move across zones, you need to install a surge protection device on the boundary of that level. You can see that the electrical power line, the antenna, the telecommunication lines are all bonded via a SPD. Other bonding measures are your masts or railings or any conductive metal that's coming from outside the zone into your building. It also needs to be bonded just via an earthing connector. If you use the example of a double-story house, you might have 2 distribution boards. Now, if you move across from a lighting level, a lighting protection zone 1 to a lighting protection zone 2, you also need to install surge protection devices on the boundaries as well. This is where the energy coordination comes from, because these 2 SPDs need to coordinate with each other. So how do we protect our systems? It's important to install surge protection devices on your power networks as well as your data networks, because damages can come from both the power and data side or the data infrastructure. So our redline products, typically, if you have a 3-phase system, in South Africa, we use a TNCS system, which means that your earth and your neutral is separated at your main distribution board. We have different SPDs that's manufactured based on the type of earthing system that you do have. So you can see from a 3-phase supply, you have your type 1 surge protection device installed in the main distribution board, with then your type 2 surge protection devices installed further down in your electrical system. You can also have more fine protection, where you have your type 3 surge protection devices installed, for instance, in your plugs, etc. So basically, all the equipment that's installed within an electrical installation has a certain rated impulse withstand voltage. This is the voltage that's determined by the manufacturer itself. So these voltages are actually, these electrical installations are tested to withstand a certain amount of impulse voltage. So what's important with an SPD is that you need to install an SPD that has a lower voltage protection level than what your equipment is rated for, which means that in a case where there's a fault event or a transient condition, the SPD will actually clamp your voltages at 1.5 kV in this example, which is below your rated withstand voltage, which means that then your system is safe. It's important in these types of installations to actually do energy coordination, where you have your type 1 and your type 2 combined surge protection device that's installed in your main service DB. Now, there's different rules associated with when to implement what SPD and where to install any additional type 2 surge protection devices. Now, let's say you have your sub DB, you can install a type 2 device because most of the lightning current has been dealt with the type 1, type 2 combined surge protection device. And if you would like, you can also install next to the terminal device as close as possible another type 2 surge protection devices, as well as a type 3 surge protection device. So these graphs actually indicate nicely what happens with cascading of different types of surge protection devices, is that you can see that our type 1, type 2 combined surge protection device can handle a 10/350 lightning impulse waveform. So it means that that SPD installed in the main distribution board actually conducts most of the electrical or the electrical fault current from lightning into ground before it reaches your other type 2 surge protection devices. So type 2 surge protection device are capable of withstanding a H-20 waveform, as well as a type 3. A type 3 gets rid of all the small residential energy that's been passed through the installation. But this is important to realize is that as you cascade surge protection devices, each protection device gets rid of most of the energy before passing it on to the next part of the installation. So at DEHN, we have our type 1 surge protection devices as well as our type 1 and type 2 combined surge protection devices. Our type 1 SPDs or combined surge protection devices will include our DEHN Ventil, as well as we have surge protection devices for different industries with different voltage levels and also different voltage protection levels. These type 1 SPDs has a wave breaker function. What this means is that a type 1 SPD is actually, the spark gaps are manufactured in a way that it takes care of most of the lightning current before it reaches another parts of your installation. We also have the type 1 surge protection device, which is our DEHN solid, which is installed specifically for your wind industry or wind turbines, as well as our integrated surge protection devices, which has integrated backup fuses. We also have a type 1 and type 2 combined surge protection devices for your DC applications, for instance, your PV industries. So the historical developments of our type 1 SPDs started in 1984. As you can see from this is that how the surge protection devices has actually changed over the years. You can see that the voltage protection levels with these older modules are still at 4 kV, and with the new technology we implemented today, the SPDs are now has a voltage level of 1.5 kV, which I explained earlier is better for electrical installations because it limits the voltage. To below your electrical rated withstand voltages. And also with this, you can see that a new spark gap technology has emerged, which is called your Radix flow. So basically what the Radix flow does is it is actually encapsulated spark gap. When a lightning current enters the spark gap, it passes through a gas emitting plastic. This gas emitting plastic releases a gas, which then extends the arc caused or created by the lightning current radially and axially to extinguish the arc. The advantages of this is that it limits the high follow current from your system. So in case where this spark gap switches on, it creates momentarily a short circuit, and this new technology actually improves this. It lowers that short circuit current coming from the source. Again, new technology that's coming out next year is that we have improved our spark gaps even further, which is now called the rapid arc control spark gap. It works with an arcing chamber with 2 electrodes. So arc actually forms between the 2 electrodes. It moves up through the arcing chamber, extinguishing the arc without any residual energy passing through the spark gap going to your terminal device. And also to mention that causes, it has a low mains follow current, which means that any upstream fuses will be protected and will not chip in this case. So there's different types of technologies associated with surge protection devices. First of all, you get your varistor type surge protection devices, which is called your voltage limiting surge protection devices. From the graph, you can see that a voltage limiting device actually limits the voltage to below a certain value, where your spark gap switches the lightning current to ground, which can be seen by this small peak on the red graph over here, and it reduces your residual voltage to nearly 0. But what we've done with our type 1, type 2 combined SPDs, we actually included this in the same surge protection device, which gives you best of both worlds. Now you have an SPD that's capable of withstanding a lightning current due to the spark gap technology, and also gives you that finer voltage protection level provided by the varistor. This is indicated in the graph as well. So you still have your switching spike, the triggering voltage for the spark gap, and then the MOV reduces the residual voltage to below a certain value. This is a test we have done in one of our laboratories in Germany. There is a comparison between coordination of the different types of components in surge protection devices. So first of all, there was only a type 1 SPD based on a varistor and a spark gap. They injected the electrical circuit with a total of 1.25 kiloamps. And you can see that from this, the green graph, that's the total current that's flowing through your spark gap itself to ground. The red graph indicates the amount of current actually passing through to your terminal device. This is way too high for the electrical device to withstand. Now with the new technology, with the rapid arc control spark gap, you can see that from the same test, most of the current was actually directed via the SPD to ground, and only a small amount of residual energy passed through to your terminal device. Prefusing and fuse selection. All our SPDs has if you go onto our website, has an installation manual, and depending on our application and the rating of your upstream circuit breaker, surge arresters in some applications might need to be prefused. Prefusing is required to protect the SPD itself from complete failure, as well as protecting or disconnecting your electrical system when there's a fault occurring within an SPD. Now, prefusing is usually required for installations, for industrial installations with large amp ratings. So you can see this is an example that's been obtained from our website, the DEHNguard. On the right-hand side, there's a graph or a table that indicates your F1, which is your upstream circuit breaker size, and F2 is the selected fuse size that you would need to prefuse this arrestor with. So you can see from, depending on the upstream circuit breaker size, depending on the application, you only need to prefuse your surge protection device when that rating becomes higher than 315 amps. You need to prefuse your surge protection device with a 315 GG fuse. As well as depending on the rating of the upstream circuit breaker, you also need to install the correct cable size for the SPD as well. To prefuse surge protection devices actually creates less space in your distribution board, because now you have to go buy fuse holders and different fuses to actually just to prefuse your surge protection devices. But we have created a solution for this, which is called our DEHNguard CI. The CI technology stands for circuit interruption. This means that the DEHNguard CI has a built-in fuse inside this SPD itself. So this actually reduces the amount of space required for installation purposes, as well as it actually makes installation much easier, because now you don't need to go size fuses. You just install the module and you know you have the correct fuse installed. It also reduces cables now connecting your SPD, which is also very important with the functionality of an SPD. This is our DEHNguard CI, which has the integrated backup fuse within the module itself. Some of our modules do have the FM contacts, which is a remote signaling contact, which you can wire any way you would like. You can light a light, or you can put a buzzer to know that the SPD has actually failed. Why it's important for the installations of SPDs, the cable lengths are also very important. The general rule of thumb is that you need to keep your cable lengths as low or short as possible. Connecting cables does have an impedance on that line, and the higher the impedance of that line becomes, lower your voltage protection level, or you actually derate your SPD. That's why they always tell you you need to install a SPD as close as possible to the terminal device. Because if there's a current flowing through this wire, there's a voltage drop across the cable, there's a residual voltage drop across the surge protection device, and there's also then a voltage drop on your earthing conductor. So now if you start putting in longer connecting lines, you're actually derating the voltage protection level. So the voltage level that the SPD switches on becomes much higher. In cases, it can be higher than your electrical installation. The general rule of thumb is that the connecting cable lines, which is your line connecting from your busboard to your SPD, as well as from the SPD's earth terminal to your earth bar, should be lower than or shorter than 1 meter. Then moving over to our type 2 surge protection devices. So our type 2 surge protection devices are also manufactured for different types of industries. So you can see that you have your residential areas, you have your single pole surge protection devices, as well as your DEHNguards, which can be installed in a plug next to your electrical equipment. We also have type 2 surge protection devices for your PV industry, as well as different type of type 2 surge protection devices based on the voltage level. So we do have a lot of different solutions for a lot of different applications. We also have moved from our type 2 surge protection devices, also had the CI technology integrated, but now we moved over to ACI, which is your advanced circuit interruption, which I will explain in the next few slides. Again, our first type 2 surge protection device, which was varistor based, was manufactured in 1954. And throughout the years, these SPDs had new technologies integrated with it. Where in 2009, we launched our CI, which was also nice because now you didn't have to worry about pre-fusing in the surge protection device. You know that it was actually taken care of. And now in 2019, we actually launched the ACI, which is your integrated switch spar gap combination. The advantages of this SPD is that there is safe dimensioning associated with that. That means that usually when selecting pre-fuses, you have to go check the upstream circuit breaker rating, and you need to select a fuse based on that. And now you have to install the correct fuse for depending on the application. So the safe dimensioning actually takes care of that. You don't have to worry about any pre-fusing because pre-fusing with this arrestor is not required. Also, safe dimensioning, this SPD is only to be required to be installed with a 6mm squared copper cable. There's no need to go check the installation instructions to see, depending on the type of installation and the upstream circuit breaker, you don't need to size cables. So it makes installation much easier and also cheaper. It also has a temporary over voltage withstand capabilities of the MOV. As you can see from the diagram on the right-hand side, this new switch spar gap technology, it's actually an open circuit. Only during fault conditions, it actually connects, and then the SPD or the MOV is connected into your system. So when you have an over voltage, the MOV isn't actually connected to your system, which is then extending the lifetime of the MOV as well. And also with the new spar gap or switch spar gap technology, you have a small lead through energy. So when most of the energy of a fault condition will actually go to ground via the SPD, and not a lot of energy will actually go through or pass through to your downstream electrical installations. Another feature for this SPD is that it has a zero leakage current. Usually with MOVs, it degrades over time and it starts leaking current, which can cause nuisance tripping. Now, this is actually dealt with due to this disconnecting element at the top, which is in normal operation open circuit, so your MOV isn't subjected to any voltage stresses over the course of its lifetime. That's why there's zero leakage currents from this device. And another nice feature of this SPD is that you don't need, if you do insulation testing, with the installation. You don't need to remove the modules. You can protect, you can actually do the testing without removing the modules, which is much easier. So we have a video that actually shows how the ACI technology actually works during a fault condition. So our ACI DEHNguard is our type 2 surge protection device. And as I mentioned, the new spark gap or switch spark gap technology provides safe dimensioning, gives you a higher temporary over voltage withstand capabilities, as well as there's a small lead through energy going through your downstream electrical devices. So this is how the SPD is made up of. If there's a H-20 coming into the SPD, an arc is generated. That arc moves through the new fancy arcing chambers, and it extinguishes the arc and directs the energy to ground. In case of a fault condition, you have a short circuit. It actually can interrupt the short circuit and disconnect the SPD when it's overstressed. The safe dimensioning is also nice with this implementation of the SPD, is because it removes the requirement of any external backup fuses. So all the connecting links or wires can be kept as short as possible. So the way not having to install fuses actually lowers your amount of cable that is required for this new ACI technology. Next year, ACI is only now available with our type 2 surge protection devices, but from next year, our DEHNguard ACI is going to be released, which is your type 1 surge protection device. Just to run over the features again of the ACI, you can see that it provides safe dimensioning. 6mm squared cables are always sufficient, independent of the upstream circuit breaker size. Also with this is you have a longer lifetime of the MOV, and also it provides you a higher withstand voltages. As well, it's the same as the other SPDs, it has overcurrent protection, which actually disconnects the SPD in overstressed conditions. And also this technology provides that you have more space in your switchgear cabinets, and you don't need to install any backup fuses. And also it gives you a type 2 protection. This is our 3-phase module. We also have the ACI technology for our 3 phases. And this, depending on the earthing configuration that you have, there's different SPDs based on, or different part numbers based on the earthing configuration. The ratings are also given on the website, so you can see that the short circuit capabilities of this SPD is at 25 kA. It can do a nominal a current of 20 kA H-20, and its operating voltage is also shown. So you can choose the correct SPD depending on the voltage levels. All of our SPDs comes with this dynamic thermal disconnect flag, which shows when an SPD has failed. Which is nice of this is that you can actually see mechanically that the surge protection device has to be removed when the flag turns red. And with our new modular type of SPDs, you can just remove the module and replace it with a new one. As well as if you have industrial applications, you can wire a remote signaling contact connection, depending on your logic that you want to use. You can wire a signal to be sent to someone that the SPD has actually failed and that it needs to be replaced. So, moving over to our yellow line products. Same with our power systems. We have different applications for your telecommunication industry as well. You can see that from our measuring systems, you have your DEHN pipes, you have your blitz ducted connects, which we will explain a little bit later on. We have the same SPD manufactured as well for your EX explosive areas. You also have your DEHN patch outdoor, which can be installed outside to protect you against for all your Ethernet applications. You have your DEHN Rapid LSA, your DEHN patch, which is for your Ethernet applications, as well as your bus detector, which is for your KNX systems. The same with your data networks, your Ethernet applications. We have the DEHN patch and a DEHN patch outdoor. Moving over to your telecommunication products, we have the Blitz Ductor and the Blitz Ductor Connect, which can be used to protect your telephone systems, as well as the DEHN Rapid LSA, which is older technology. The same for your coaxial antenna technology. We have surge protection devices protecting these systems as well. So you have your DEHN gate, which can be used to protect your coaxial systems and your antennas. And there's different modules and types of SPDs based on the protection that you need. So one very important thing with the difference between communication SPDs and our power SPDs is that the SPDs which is used in telecommunication systems are actually installed in series. Our power system installations are done in parallel. So installation for your telecommunication is very important. As to keep your protection should be installed as far away as possible from your protected side. You shouldn't loop the conductors next to each other, because if a fault current or fault events happens to come onto one of these lines, the inducing effect will actually create a fault condition or a transient overvoltage on the other side of the SPD. So you're in essence actually bypassing the whole protection of this SPD. To give you an example of a typical installation, now you have your Blitz ductors installed in a cabinet. Now you wide your insides, which is your protected or unprotected sides, with your protected sides together. Now with this, you cause into induction loops. So the fault current actually goes onto your clean ends to your terminal device. The correct way of installing this is actually to install all the cables or all the clean sides next to each other. So there's different ways of actually detect if communication SPDs are actually damaged. We have two different types of bases which we use. Normally we have a base that's normally open, and then we also have a base that's normally closed. So depending on the installation, if it's very critical, customers often tend to have a base that's normally open. So when you remove your protection module, the signals actually be disconnected. They like it in the applications because if there's no surge protection device installed, the SPD or the line is not subjected to any transient conditions. But in cases, it's required that the signal should continue if the module has been removed. In that case, the normally closed base is installed. Yes. So earthing also through this is done through the DIN rail as well. So there's no additional need for earthing cables for this SPD. Some of our SPDs has this Lifecheck function, which works with an RFID chip. You can actually check if the SPD has failed or not. And this is also maintenance free. This is a very nice way with our DEHNguard, which I'll show later, how to check if this SPD is actually still functional or not. So this uses a RFID chip, which is installed in the module. And with our DEHNguard, you can actually monitor to check if the SPD is actually is still functional or not. The test is quite easy. You have a pass and fail light You connect the protection module as it is in the image, and you press test, and depending on the information received from the RFID chip, you can see if the SPD has actually failed or not. We also have a much more fancier DEHNguard device, which can tell you that the SPD is okay, and you might need to consider it later on. It gives you expected lifetime of an SPD. And this is nice. This DEHNguard is because you don't have to do any maintenance on it. It's very easy to actually test the functionality of the SPD, as well as it's a galvanically isolated measurement. So there's no need to disconnect any wires for actually testing the SPD. So our blitz ductor product history actually started in 1979 with the first blitz ductor, and throughout the years it actually evolved and became much smaller. And in 2006 we launched the blitz ductor XT, and now in 2020 we actually released the new blitz ductor Connect. These features are going to explain also in the later slides. Okay, so first of all, from the image, you can see that the blitz ductor Connect is much smaller. It's about half the size of the normal blitz ductor, which actually increases the space in your distribution board or your cabinet. Also, they changed the design a bit now with 45-degree pushing terminals. Also, a nice function of this is that you have a wire push button which actually opens contacts, so you don't need any installation tools to install this SPD. It has a test port where with certain measurements you can actually test the base and the module to see if it's actually still functional. You also have a reverse polarity protection module base that prevents you from actually putting in the SPD the wrong way. And also, same as our power SPDs, it has an overload fault mode. In a case where the SPD is overloaded, it actually mechanically disconnects the SPD from your system. Also implemented in this SPD, it also has a Lifecheck monitoring system that can be installed with the use of this blitz ductor Connects. And also you can see that from the window, you can check if the SPD is still functional or not. With new clips installed, which we call the secure release, the modules, because it's small, it's actually easy if it's installed next to each other to actually remove the wrong module. But now they included this new secure release technology, which actually it's clips that you can clip open before removing the module. And the same as with the previous one, earthing is done via the DIN rail. So if you have installation of a lot of these blitz ductor Connects installed, you can actually implement a monitoring system which does active monitoring. So you're supplied with an external voltage or power source. And this works through actually determining which SPD has failed. So how this works is it works with a transmitter and a receiver. So two bases or signaling contacts are placed on either ends, and it uses an infrared light to measure the system. Now, if a flag has SPD has thermally overloaded, it actually closes the flag and it closes the part where the signal passes. So now no signal can actually go through to your SPD. This shows or indicates that the SPD has failed and you need to replace. That's very nice for this because if you have large industrial applications, it's not always feasible to go through your installation every day to check if SPD has failed. You can use this new signaling remote contacts to actually monitor your systems and to see which SPDs needs to be replaced. Yes, so thanks. This concludes the presentation of our SPDs and as well as for our power and yellow line. And thanks for your attention.
Okay, great. Thanks so much, Stefan. Thanks, Alan. I think this has been a very informative webinar. Just to let everybody know, the webinar recording will be emailed through to you in the next 48 hours. So again, thank you so much, Den, for all the informative information. I'm going to launch the poll now. If you wouldn't mind just taking a few minutes of your time just to answer a couple of questions related to the webinar. If you do have any questions, please, if you have a look on the chat function, you can see Stefan's email address is there. You're welcome to email him directly or send any queries through to info@em, and we will attend to them as soon as possible. But on the whole, thanks very much, Den, and have a great day, everybody.
Thank you very much.